All right, so we're still doing finance, growth, and decay. All right, so sometimes the problem. Oh, sorry, I'm so tired. Sometimes we were given the, let's say on a target, ne? I get sometimes savers you'll be saving money, and your goal is to say, I have 1,000 now. I wanna have 5,000 after a certain amount of time. Maybe let's say 10 years or something, and this you put in an investment or savings account, right? So we can still use the same formula, compound formula, and simple interest, compound and simple interest, to work out the principal amount, the interest rate, or the time period. Ne? So sometimes we have A, and we can find P, I, or N using simple or compound interest formula. Ne? So let's go straight into the example. You want to invest money now so that after 5 years, that money gains, or after 5 years at 8% simple interest, you will have 4,200. So targeta 4,200. Your interest is gonna be 8%, and you're gonna plan this over 5 years. Ne? So interest is simple, ne? Which formula are we going to use? According to you. Let me just share screen. Oh, wait. Let me share screen so that in case. There we go. Alright. So arre go sone. Onyaka wale 4,200 after 5 years. Wale 4.2 after 5 years at a simple interest 8%. Now we did run this calculation now level, like according to you. How would we do the calculation? You can open your mic and then roll it. Ne? Hello. Magdalene. Are you still there?
Yeah.
Oh, okay. So refer the simple interest is 8%. We're given the simple interest as 8%. It will be invested over 5 years, so that after 5 years, we'll have 4.2. Formula and how would we go about the calculation?
Compound.
But a simple interest rate, remember?
Oh, okay.
So toshumisha formula.
Yeah, simple.
Yeah, simple, ne?
Yeah,
simple. So it will be A into P times 1 plus N times I. And then substitute again. So that will be 4,200. P are because we need to find out how much you will invest. Interest 8 over 100. And the number of years give 5. So answer, how will we find it? We will have to do some math here. Ne? Now what I would do, what I would attempt to do is to multiply 0.08 by 5. So 0.08 times 5 plus 1. So that is 1.4. 4200. Then I take the multiplicative inverse, times 4200, and then so that's the amount of money that must be invested initially. Ne? So the question mokine gore this time to the bank. To the bank, and we're gonna invest money. Now we don't know how much we need to invest so that at the end of 5 years at a simple interest rate we get 4.2. So we then do the math and then recalculate. Maramoki, the most important thing you can notice is that we work in reverse, so to speak, ne? And manipulate the formula to make any of the unknowns the subject. Now, why would we do this? It's because we may want to find at some point, let's say we don't have the number of years that needs to be spent investing the money. So we'll have to make this subject of formula. So we'll have to do distributive rule, the same rules from algebra. We have to apply them, divide by that, etc. So that's if we want to find that, or the same as if we want to find that. And then we just punch it back into our calculator, and that will give us the answer. So in this case, the goal was to find the principal amount of 2 million, the amount that we started with, so that we can then estimate over 5 years at a simple interest rate, how much would we need to invest to get 4.2. That one is quite simple, ne? It's quite straightforward, ne? Remember yesterday we talked about the population increase, modeling population studies. So now let's look at a population of a town. We don't know what town it is, but let's picture we are calculating population as Sheo, which is where we are. Sheo Moleji. So the surrounds of Polokwane. Let's imagine we are doing that. And although this is not necessarily the population here, but we're trying to picture it as though the population tower. I got you've seen was there are places that are extending, like Bo Zone Mamang extension, we're getting extension 44, extension 133, because our town is growing, people are increasing in number, people are having babies after they finish school, some in school. Not that I'm promoting that, but it's just something that would happen, that can happen. Then at a certain point, people start having their own families, the homes they grew up in get too large, so the population grows. Then you get like Juju Valley, you get extension 133, you get Lutuli. So let's say a population of a town grows from 12,000 people to 214,000 people. That's a lot of growth. That's a lot of growth. Maybe it's not people, maybe it's something else. Maybe it's it's cows in a farm that are being bred for meat. Let's say that's the case. Or maybe it's chickens. Yeah, maybe it's chickens. Okay. Yeah, I lose you. I think I lost you. But anyway, I'll just continue. So the compound. Oh yeah, I lost you there, ne? Hey, Magdalene. I lost you there, ne? Did you get disconnected? Oh, okay. We can continue. Alright. So our population grows from 12,000 people, or 12,000 to 214,000. So maybe let's not say people, let's just keep it general. But the early example was just to show how we would try and visualize population growth from where we live. Yeah, man. So Shiro wasn't always this big. It was a few zones, maybe 1, 2, and 3, I think, and maybe 4 as well. And then after some time, you had zone 5, and then zone 6. Then you had extension 44, 133, literally, and the like. Muleji, also like that. We used to have Moto, Maperigesi, and other ones. And then now you have Jerusalem, Mtinti. So as people increase in numbers, the population grows, then the urban planning also changes. People, Maspala maybe Sarastene or Marosha Sarastene, this 10 for what, and then people expand, people, fill up the territory. Yeah, so that's what happens. So we must find this is in 10 years, ne? So that's important. So we must find the compound annual growth rate, ne, of the population. How do we find that? Which formula are we going to use, simple or compound? Yeah?
I think we could use the compound.
Compound, okay. So compound would be A equals P into 1 plus I to the power N. Okay, so the information that we learn here, what does it tell us what it is that we should look for? If we are to write down the things that we know and the things we don't know, which one must we calculate? So let's start looking at the things that we know. What do we know to start with? What do we know?
Number of years.
Oh, no, we have number of years. Okay, we have number of years at the beginning and at the end of 10 years, yeah? Hey, Magdalene. We have, okay, tell me something. This 12,000, between A and P, the final and principal amounts or numbers. This 12,000 and 214,000.
Between
These two numbers, 12,000 and 214,000. What do they tell us about the principal and the final?
I think 12,000 a
A.
then 214,000 a.
Okay, so principal is 12,000, that's very good. And then final would be 214,000. Okay, and then what does this 10-year period represent? What does the 10 years represent on the formula there?
It represents a
N, eh? 10 years. Okay, that's good. So things we don't know
the I.
is the interest rate or the compound annual growth rate. Okay, so then we can substitute. So we'll have 214,000 equals 12,000. This is into 1 plus I to the power of 10. Yeah? So the next step we do is take multiplicative inverses. So we will have 214 divided by 12,000 elegantly 1 plus I to power 10. Now maybe let's shift that up there. So then we will have to take the 10th root of 214,000 over 12,000. And that equals 1 plus I. Let me ask you this step where we now change from that so that we are left with just 1 plus I. Do you follow how we get there? Step aseki, do you understand it? This one.
Also, sa after yan.
Yes.
Oh yeah, I understand. Number of years.
Yes, that's correct. That's correct. So that we can remove this exponent on this side and put it to the other side. Okay, that's good. You know how to do it, right, for yourself? Yeah. You know how to do it, Mus, in like a test or. You know how to do it, ne?
Yeah.
Okay, cool. Then this leaves us with interest rate equaling, if we take additive inverses, the 10th root of 214,000 over 12,000 minus 1. And the answer would be 214 divided by 12. Okay. Then we take the 10th root, 1.338999 something. So 1.3338999939 minus 1. And then this minus 1 equals 0.3338 something. And now we need to times it by 100 to get a percent. So I would be and this is times 100. Whoa. Therefore, 33.4%. So that population grew by 33.4%. So it means that it was, so over 10 years, the population compounded by 33%. It grew by 33%. Okay?
Okay. Yeah.
You understand, eh?
I understand.
Alright. Then another one that we're going to do. Yeah, ask.
How many marks?
That one is usually. Oh, this one would be okay. They didn't specify the number of marks here. They didn't specify the number of marks here. But we're gonna do ones that have the number of marks specified. So this one is just gonna show us how we can play around with the formula. So don't worry about the marks for now. So this one was just showing us how we use. So let me just put in blue here. Ne? So here we eliminate exponent outside of bracket. Ne? In the first one, we're solving. Oh, okay. This one is straightforward. It's just it's mostly multiplicative inverses here. Multiplicative inverse, ne? Moki, we are eliminating the exponent outside the bracket. And then the third one, we will use log. Have you worked with logarithm before? Log equations.
Yeah.
Logarithm.
No.
You have not? Okay.
Yeah.
It's fine. So you'll learn something about logs today. So let's say your sister puts away your sister puts away 3,500, ne? $3.5 into saving account, and the savings account pays 7.5% per annum, or a yearly interest of 7.5% compound, ne? So compound interest. After some years, after some time, ne, the savings mature to 4,044 rand 69 cents. So now we must find how long was this money invested for. So here we will need to again use compound interest, but let's just state for now the things that we know. So 3,500, is that the principal or final amount?
The principal.
It's the principal, ne? Because it's what was initially saved. That's correct. And then what is the 4,044 rand 69?
The final amount.
It's the final, ne? The 7.5 per annum compound interest is then what we will assume the 7.5%. So it is 7.5 divided by 100. That is 0.075. Okay? So if we use A equals P into 1 plus I to power n, then 4044.69 equals 3500 1 plus 0.075 to power n. Then we will divide, and this will give us 4044.69 over 3500. This equals 1.75 to the power n. Now I want you to remember something. You remember in exponents, we will have a number to the power n, right? Remember in exponents, we will have this. Now, in order for us, let's say we are using numbers, we would have 2 to the power x. Maybe let's say it equals something. Let's say it equals 8, Then we know that 2 to the power x equals 2 to the power 3, because 8 equals 2 times 2 times 2. So 2 times 2 is 4, times 2 gives you 8. Then we can simply say that x equals 3. I'm sure you've come across something like this before, have you not?
Yeah.
You have, Okay. Now, we have a similar situation here. Because we're going to get a decimal number, 1 point something. So it's 1.075, not 1.75. It's going to equal 1.075 to the power n. So we must find out what this is, which power this number is raised to, so that if we raise 1.075 to a power, then that power equals whatever power this is raised to. So that is what we call a logarithm. Now on your calculator you'll see log something something. Now I'm just going to show you a short trick on how we use logs. The calculator uses the log of 10, for example, will give you 1. And I think the log of 1 will give you 0. Just punch it in on your calculator, you'll see. So log of 100 will give you 2. Log of 1,000 will give you 3. So just punch those in on your calculator and see if what I'm saying is true. Is it true? Magdalene? Hello? Yeah, so you got these,
Yeah.
Okay, cool. So our calculator by default, it uses base 10. So in other words, what it means is that this is a base, base 2. Base 2. So in the same way, if we want to remove the log there and go back to exponential form, log is an inverse of exponential form, by the way. So this means we will have to say the base of 10 when raised to the power 1 equals 10. the base of 10 when raised to the power 0 equals 1. And of course, every number raised to the power 0 equals 1. Remember that was from exponents. The
Yeah.
base that we must raise to the power 2 gives us 100. The base of 10 that we must raise to the power 3 gives us 1,000. So that's how logs work. And when you look at this in function form, when you get to grade 12, you'll do functions, and you will also do inverse of functions. You will see that this exponent form has a graph that looks like this. Ne? Because at x equals 0, this is y equals a to the power x. So at x equals 0, you get 1, and that's the value of the y-axis. Now its inverse is mirrored around the y equals x line, and it looks something like that. Where so this is just to show visually in function form that this is y equal log x, right? To whatever base. So it's just a crash course in logarithms. I'm probably skipping a lot of important concepts, and we will get to this, and I'll make a video of a class where we discuss the log function as an inverse of exponents. But I just want to illustrate the point. So we're going to use the same concept here. So when we divide 4,044 Rand 69 cents with 3,500, we get 1.1556 something, right? And this is to the power n. So what we're going to do in the next stage is something similar to what we did just over here. Ne? And what we're going to do is that n becomes the logarithm to base 1.075. Remember, in this exponent form, this is our base, 1.075. So we write that as a base. Now we have to make this explicitly a base because by default, our calculator uses base 10. So we will have to work with base 1.075. But our calculator doesn't have that, so I'll show you how you calculate that on your how you use that on your calculator. So the base is 1.075. Now we need to find the log of 1.1556 something. And what we can do is, I'm out of space on this slide. We would have n equals log of 1.1552 something divide by the log of 1.075. Now this is because in logarithms, if we have log of a to base b, it is the same as the log of a to base 10 over the log of b to base 10, or to a different base, right? And we simply punch that into a calculator, and that gives us 2.00058,543, which is roughly equal to 2 years. That's how long your sister must invest that money for. So I'll just switch to the next slide so you can see. But yeah, that money needs to be saved for about 2 years in that account. So logarithmic form you will learn, but this is one of the log rules. You'll get to learn them, so don't be impatient about that. But it's just one of the ways that logs become important in solving for these types of problems. Now we're going to do problems with marks. Are you ready? All right. Someone borrows money from a bank. In this example, let's call it a marked problem. So it's marked. It's a marked problem. Number 1. So amount borrowed is unknown, but the compound interest rate is 15%, and it's compounded quarterly. Remember that thing about compounding at different times within the period of a year? So compounded quarterly, remember, it will be divided by 4 or something to the power, or rather something in 4 parts, because there's 4 quarters in a year. All right. So after 3 years, $7,000 is owed. 7,000 is owed. Ne? How much was borrowed? How much was borrowed? That's what we're going to find out. Ne? So for 3 marks, ne? So for 3 marks, okay, tell me something. We're told that after 3 years, 7,000 is owed. What do you think that tells us with respect to the formula A equals P into 1 plus I to power N? What do you think this information tells us, just this part here, in terms of this formula?
I think when maybe kalau nanti interest maybe I think maybe
I can't remember what we're No, say. Let me not interrupt. Say.
P. A.
We're looking for P.
P, I think.
Oh, okay. That's good. I like that you identified that. So if Renyaga P, that's fine. So now what does the 7,000 tell us in terms of the formula? What is the 7,000 then?
The 7,000 is the final amount record.
Oh, okay. So this is A. That's good. And then we know that we have 3-year period, ne? Okay, so A is 7,000. We know that N is the period. But now we've got this interest compounded every quarter. Now, how many quarters do we have in a year?
4.
4, okay. So we will have to multiply the 3 years by 4 so that we get 12 quarters in total. Isn't it so?
Yeah.
All right. Then about the interest rate. The interest rate is 15%, but remember it's compounded quarterly. So how do we then work it out? So it's 15%.
Oh, divide by 100.
Yes, it's 15 divided by 100. But now, where does the quarter that is going to be compounded into go in this equation?
It will be key interest, ne?
Yeah, interest.
It's about, we'll divide 1/4.
Yeah, so we'll multiply by 1 over 4. That's excellent. Yes. So we'll multiply by a quarter. And then that's our interest rate. So this will be 0.15 divided by 4. Okay, so now we have to find P. And this should equal A divided by 1 plus I to power n, which is 7,000 divided by 1 plus 0.15 over 4. And this is to the power 12. And that will give us our final answer when we substitute and we calculate. So what this will be is 0.15 divided by 4 plus 1 and to power 12. Then we invert it and we times it by 7,000. And that gives us 4,529 cents. One of this one looks like the first example that we tried. And where you get marks here is in the correct identification of the interest rate, the correct substitution, as well as the final answer. That's where you get your 3 marks. The second type of problem, so it's a marked example. So number 2, okay, so in this case, 1,570 is invested, and the compound interest is 12% yearly. How many years will it take? So how long will it take? So how long until the money grows to 23,000? That's what we must find. Yeah. This one, what do you think it tells us? What's this amount here? 1,750.
I think the 1,100 and 1,500 and 70 is the P.
It's the principal amount. Okay, that's good. And then what is the 23,000?
Then, yeah?
23,000 Yona is what?
The final amount, the age.
Okay, that's good. That's good.
Yeah, sorry, Nakadam.
So we are yes, we're looking for the number of years, which is n, right? So we've got our interest rate, and we must find n. So A equals P into 1 plus interest rate to power n. I am going to solve for n before substituting so that I have A divided by P equals 1 plus I to power n. Then I take the logs. So the log to base 1 plus I of a divided by p will equal n. Then I substitute. So if my interest rate is 12%, that equals 12 over 100, which is 0.12. Then what I will have is log to base 1.12 of 23,000 divided by 1,570. And this equals log of, I'm going to take to base 10, 23,000 over, oh, I'm making so many writing errors there. To base 10 of 1.12. So I'm just going to put in the base 10 so that you and I always remember that on the calculator, our calculator uses base 10. But we don't need to do that if we are going to shift from this notation to that notation. And
so
now...
the a divided by p, the exponent must... The exponent.
The exponent is she. So...
n is equals to log after a.
Oh, no. It's not an exponent. No. At this point, a divided by p is not an exponent. And thank you for that question. The reason is we are looking for the logarithm of a divided by p. We're looking for the log of a divided by p at base of that. And remember, in terms of exponents, this is our base and this is our exponent. And the exponent we are looking for is this one, there. It sounds a bit confusing for now for you, and I understand why. But for now, just take it at face value because you haven't learned the theory of logarithms. But for now, just take it at face value that, what's this? That this is not the exponent in this case. This part is not an exponent in this case. This is because in the context of this equation, we are looking for like what power would that be so that when we raise this base to that power, we get the 23,000 divided by 1,570. Okay, that's how logarithms work. It's still an exponent, but we're thinking about an exponent in reverse order. That's how logs work. In inverse order. Yeah, remember an inverse is like a reverse order. So think about, for now, logs are like the reverse of exponents. Okay, so now we're gonna work out this in the calculator. So 23,000 divided by 1,570 equals, and then we take the log, so it's 1.1 something something, so it's 1.165 something something something. This is divided by, open bracket, 1.12 log. That equals, okay, maybe let me not write that because I didn't write down the log 112. That gives us 23.69 years. So roughly 24 years. Okay. And again, this is the type of example where we are using now the exponents and log rules to find the duration or the period over which that investment must be made. Okay. And again, we have to use logarithmic laws. Again, we'll have a class where we teach logarithms. For you, this is an advantage since you're in grade 11. So by the time you get to do them in the next grade, you will enjoy the benefit of having been exposed to them before. So it's very nice to study with Mr. P, ne? Yeah, no, it's very good for you. I'm glad to hear you laughing. So again, this problem is a 4 marks question. So you will get, for the correct substitution, I suppose, you'll get marks for the correct substitution. You will get marks for 2 marks for the correct substitution. A mark for that identification of the log, which is at this part here. And for rounding off to the nearest year. So I'm going about it how I find comfort in solving problems, so that I work out the equation first, make the concerned the subject of the formula, and then substitute and give the answer. So that's how it works simpler for me. You're more than welcome to substitute and then calculate. I often find that it confuses me during the calculation. So I'd much rather just simplify the equation, make that a subject of formula, and then substitute and get the answer. The last problem, which has 4 marks as well, would be, so number 3, where we are advised that initially 2,000 rands is saved, or invested in a fund that pays interest that is compounded monthly, ne? And so interest is compounded monthly. Not interested, interest is compounded monthly. Okay, so at 18 months, the fund matured or grew to, let's say, 2,860. We must find the interest rate. So from the information that we have, what would you say we have when we think about this amount of 2,000? So according to our formula, A equals P into 1 plus I to power n. What would you say we are given for this equation if we are looking at this number here?
The 2,000.
Yeah.
P. Then.
Okay.
Yeah, we A.
Okay.
Then 18 months the N. Para may kada I.
All right. So N is 18. P is 2000. And A is 2860. Then I is unknown. Therefore, we substitute 2. Okay. Okay, let's do it the conventional way. So we'll have 2860 equals 2000 into 1 plus I. Remember, the interest is compounded monthly. So we must divide I by 12. All right? Because this is the same as 12 times... Or rather, let me not go there. Let's not go there. Yeah. So then we would divide 2860 by 2000. And this will give us, to the power 18, 1 plus I divided by 12. Okay. So that means this, the 18th root of 2860 over 2000 will equal 1 plus I divided by 12, and the 18th root of 2860 over 2000 minus 1 equals I divided by 12, and all of this 12 times 18th root of 2860 over 2000 minus 1. This minus 1 is outside of the third sign, this sign, a square root. It's outside of it. And that will give us I'll start with 2860 divided by 2000. I'll take the eighteenth root of that. I'll subtract 1, and I'll multiply that by 12, and then I get 0.2408, and I times by 100. Therefore, the interest rate would be 24.08%. So this is an example of the third one that we did, and here you'll get marks for the correct substitution. For the multiplicative inverse maybe, and perhaps for getting to this stage. 1, 2, 3, and also for your interest rate in percent 4. Now there's another part. So now we're going to discuss something called decay or depreciation. So decay or depreciation, what are these? What do you think decay is or depreciation? Hey Magdalene, what do you think depreciation is?
Decay.
Decay. Yeah, what do you think it is?
I think I think maybe game. I don't have any idea. Okay.
You don't have any idea. Okay, that's fine, and I don't blame you. I mean, most teenagers in grade 11 will be thinking, I don't need to buy an asset that appreciates or an asset that depreciates. Many teenagers would probably not be thinking about that. But azanga wakwaba toblela gare, reganto, it grows in value, or koloi or phone, it shrinks in value. Have you ever heard that before?
Oh yeah, I've had. I think maybe game. Maybe it describe process yang amount.
Okay, that's good. That's good. It's good that you identified that. So, in other words, it's the amount of money that an asset would lose value through use and age, right? So, a lot of electronic equipment, for example, laptop, tablet that I'm using, the phone that you're using, they would depreciate in value with use and time. So if I bought a laptop that's worth 60,000 rands in 2022, then because I've been using it since 2022 and 2 years have passed and I've been using it every day, then it depreciates by a certain amount. A car is the same thing. I drive it every day to and from work. Meaning I'll go from here to Bloemfontein or from here to Cape Town or from here to Bulawayo in Zimbabwe for one reason or another. And because I'm using that car every now and then, the value that I bought it for, let's say it's a van that I get things with in Tanin that I go sell in Northern Cape. Because it travels those distances, okay, the kilometer, and then the kilometer, the mileage increases, and when the mileage increases, the engine the engine gets tired because it's getting used and used and used. Even if I service it, yes, I'll service it, but it's got mileage. It's been getting used, so it's not as brand new. It's not like it's brand new where the engine has not been used by the time it leaves the garage where it's bought. On laptop, same thing. Cell phone, same thing. So the price that you pay for a brand new car is therefore higher than the price that you pay for a car that's been used. So used or pre-owned car dealerships would sell the same car for much less, for a lot less. So that's where decay comes from. So now we're going to work out how you calculate that depreciation. And there's simple decay and there's also compound decay. So we're gonna jump right into it. So we're gonna start off with simple decay or simple depreciation. Yeah? So simple depreciation, it's like the opposite formula for simple interest. You can also think about it as simple depreciation is the opposite of simple appreciation, and compound depreciation is the opposite of compound appreciation, because that growth is called an appreciation. Ne? So simple depreciation is given in this formula here. And it's also called straight line depreciation. Do you want to know why? Or do you want to guess why? Let's start there. Would you like to guess why it's called straight line depreciation? This formula is also called straight line depreciation. You want to know why? Okay. So the reason for why it's called straight line depreciation is because our level of this formula, ne? It's also in the form of the function y equals mx plus c. So our principal amount doesn't change. But yes, and also the function y equals to mx plus c, the variable that changes, the component of the equation that changes, which is x, is to the power 1. It's to the power 1. So in other words, the number of years to the power of 1 doesn't change. The gradient is there, so this would be a y-intercept. So this equation is to the order of 1, so it will be a straight line. So depreciation would look like that, but appreciation or interest would look something like that. So now let's get straight into an example. It doesn't have marks, it's just to introduce the concept. So how that would work, we have a car is valued at 120,000, ne? And it depreciates. So value of an 12% yearly, ne? So after 5 years, how much will it be if we regamo? Because now it's pre-owned. After 5 years, it's been used. What is the value? After 5 years, ne? So, according to this information, when we have this amount, what do you think we have in terms of this formula here?
We have, I think, 12,000 euro to the T.
Oh, good. By the way, Ken's a mistake in it. It's 120,000, yes. So yes, it is the principal amount, because it wouldn't make sense for a car to be 12,000 brand new. Not in South Africa. Yeah, not in South Africa. No, not brand new car for 12,000. So yes, you are correct. This is the principal amount. So P is 120K. Okay. The interest rate, it's 12%, so it'll be 12 over 100, which is 0.12. Yes. And then we've got the number of years, which is 5 years. So if we use that formula, 1 minus n times I, and we substitute, so we don't know what A is, ne? So we'll have to find that. So principal amount is 120K. This is times 1 into 5 times 0.12. And let's just go with, so 5 times 0.12 equals 0.6 negative plus 1 equals 0.4, and we times that by the principal amount. So if we're talking about depreciation, I agree, we said the value is going to be less, ne? We said the value is going to be less than the original price. The price after 5 years will be less than the price at the beginning, I get. Okay, so then we get 48K. So 48,000 is less than 120,000. Sorry. Yeah, let me just put my phone on silent so that I don't disrespect you and the viewers of the video. I did not do that before, so I'll just put the phone on silent now so that I don't make that mistake again. Yes. So because this is less than the principal amount, then it's correct. Why one? Yeah, it is correct.
So meaning
Uh-huh.
every time you can keep it less than the P higher.
100%. The amount at a later stage must be less than the amount initial. You are 100% correct. Full marks. Well done. Well done. Well done. Well done. Well done. So yeah, so even with the compound, it will be like that. Even with the compound, it will be like that. That one. So let's take the same car, but this time the interest rate is compound depreciation. Sorry, the depreciation rate is compounded. Ne? So same car costs 120k, and the compound depreciation rate equals 12%, and we need to find how much it will cost after 5 years. Ne? So after 5 years, how much will car cost? Ne? So I believe you can get information on depreciation rates of assets, different types of assets. I'm not sure if it's from accountants or actuaries, but I'm sure Google search would give you some results, or maybe even ChatGPT. So if, let's say, you want to start a business, or you want to sell off an asset so that you can get money for it, maybe you're broke and you want to maybe you're cash strapped, or you're short money, or you want to trade it in, let's say you're buying a new car, but you want to trade in your old car. So obviously you'll get some money for the old car. I see zero balance. It's not worth zero. It's worth something, just not the cost price when you bought it at first. But for whatever reason, and you want to top up that money so you can get a new car or a new asset, or to sell it off so that you can get cash so you can buy something else, or sell off assets so that you can have cash flow for your business. Doesn't matter the reason, but you just want to sell off assets. You can find that information. I believe there are plenty of sources of the internet, but I also think actuaries and accountants is where you'll get that information. But we are going to calculate, because now for some reason we know the compound depreciation rate, and that depreciation rate is equals to 12% yearly, ne, per annum. So if it is 12% yearly, we are going to use the compound depreciation rate formula, which is 1 minus I instead of 1 plus I to power n. So after this, we're just going to do a comparison between simple interest. Ask your question. Oh, okay, sorry about that. Slide has been changed, no worry. Right, so the compound interest or compound depreciation formula, it's almost the same as that of compound interest, but the difference is the change in the sign there. So in other words, where you had a compound interest increase like that for A equals P into 1 plus I to power n, then this one will depreciate like that, right? And this would be a into equals p into 1 minus I to power n. So this is kind of like if you think about y equals e to the x, then this would be y equals e to the negative x. So same with functions, this one will also be, yeah. And by the way, this is called depreciation on a reducing balance, ne? Depreciation on a reducing balance, ne? Depreciation on a reducing balance, because the interest is calculated on the amount left over as it decreases, and the amount left over is called the reducing balance, ne? But let's just get to an example. So in this case, we know our principal amount is 120,000 and we are looking for A, which is our final amount. So obviously it has to be less than the principal amount, and we're going to substitute. So 120k into 1 minus interest rate is 0.12, and the period is 5 years, ne? So this gives us 1.12 to the power 5, and we, oh no, it's not 1.12, my mistake. It's okay, let's clear the memory. It's 100 minus 12 is 88, so 0.88 to the power 5, and we multiply that by 120 thou, and this gives us 63,327 rands 83 cents, ne? So obviously this is less than 120k, so also looks all right. But now let's compare. Well, one of this, the value of the car, if we're looking at compound depreciation rate, it's more than the value of the car if we're looking at simple depreciation rate. And what that tells us is that it looks like if you're going to look for a depreciation rate, because I mean, some of these assets depreciate, you're probably better off looking at a compound depreciation rate, but you'll have to do some math. So I won't speak for all cases, but you'll have to do the math so that you can prove that in a particular case, whether it's simple or compound, then which interest rate is better. All right. So we're going to do an activity whereby we compare straight line depreciation versus reducing balance depreciation, ne? And this one is for 6 marks, so you will get to see how the marks are allocated, ne? But before we do it, let's just compare, ne? So simple interest is A equals P into 1 plus N times I, or rather, and compound interest is A equals P into 1 plus I to power N, whereas simple decay or depreciation is A equals P into 1 minus N times I, and compound or reducing balance depreciation is A equals P into 1 minus I to power n. Ne? So you can keep this in mind for future. And then, yeah, so we'll do this example for 6 marks. And then we will close here for the day, so that on Monday we'll do the problem that your classmate wanted to do but couldn't. But we'll just do that problem so that he can understand, and others who might have a similar problem. In fact, we'll probably do that as a separate video, so that on Monday we can do a different chapter. But I think this will help you cover a lot about finance. Right? In fact, I think we'll continue on Monday so that we do nominal and effective interest rates and investments with time and interest rate changes. Yeah, I think we'll just do that. And then annuities. Let's see. It seems like my connection got lost there, but it will come back. My connection got lost. It got lost. Yeah, so we are back, ne? Let me share screen. How many minutes? 44 minutes to go. Right, sharing Jamboard. Yeah, I got disconnected there, ne? Sorry about that. All right, so we have a piece of machinery. This is a marked example for an example. Ne? We've got a piece of machinery. We don't know what machinery this is. Ne? But we know that it depreciates from 10,000 rands to 5,000 or 5,000 rands, ne? In 4 years. Okay, so we must find the rate of depreciation, find rate of depreciation, if in case A we use straight line method, if using straight line method, and in the second case if we are using a reducing balance method, ne? Reducing balance method. So we'll do this. Yeah. So we have a final amount of A and a principal amount of P. Do you agree? Hi, Bo. Why is this? Oh, I made 2 slides ahead. Oh, I'm sorry about that. Yeah, so we have a final amount of A, closing amount of 5,000, and an initial amount of 10,000 or principal. We've got the term, so we must find I, ne? So in the first case, straight line method, remember it's P into 1 minus n times I. And in the compound method, it is P into 1 minus I to power n. Ne? So we will substitute in both cases. So we'll have 5,000 equals 10,000 into 1 minus 4 times I. And here we'll have 5,000 equals 10,000 into 1 minus I to power 4. Taking multiplicative inverses, that's 0.5, 0.5. That equals 1 minus 4i to power 4 in that end. And then on this end, we take additive inverses. So negative 0.5 will equal negative 4i. Taking multiplicative inverses again, I would equal 0.5 divided by 4, which is and here we'll take not logs, sorry, the fourth root of 0.5 will equal 1 minus I. We take the fourth root of 0.5 minus 1 equals negative I. We divide by negative 1 on both sides, so we'll have I equals 1 minus the fourth root of 0.5, which should be positive because this number here seems like it's significantly lower than that. I mean, the square root of half is probably much smaller than 1, so the fourth root of half should be much smaller than 1. And then here we get so it's 1 over 2 times a quarter, which is I guess 12.5 percent. So 1 divided by 8 is 0.125 times 100 gives us 12.5%. And here we will get the fourth root of a half, and we subtract that from 1, and hold up. I have 0.5, and I take the fourth root of it. Yes, it's 0.84. It's not to the power 4, it's the fourth root. And then I subtract that from 1. This equals 0.159 something, and the interest rate should equal, if I multiply this by 100, 15.9%. So what does this tell us? The depreciation seems to be more with the compound depreciation. But here's where you're going to get marks. You'll get marks here for the correct substitution. You get marks there, and you get marks at the final answer. And on this end, you will get marks here for correct substitution, for processing, and for correct answer. Ne? So this question is worth 6 marks. In a grade 12 exam or test situation. But yeah, we just illustrated how you would get those marks in either case. Are there any questions? We'll stop here for today. I just want to find out if you've got questions.
Okay.
No questions?
No question.
All right. Let's end here, and then I'll see you for science class in about an hour. Is that okay?
Okay, fine.
All right. We'll talk during science class in an hour.
Okay.
Sharp. Thank you so much. And